question tells us that this reagent will only react with one equivalent of the cyanide anion, even though there are two leaving groups, and even though we're using an excess of the cyanide nucleophile. It's supposed to rationalize why that is and predict the actual product. You might be tempted to think the reaction will occur at the primary bromide because primary bromides are typically less sterically hindered than a secondary bromide. However, in this case, it is not true. What we want to focus on is these two methyl groups. Notice they're on the beta carbon with respect to the leaving group. When we have a beta branched alkyl halide, when we have a quaternary carbon adjacent to a leaving group, this quaternary carbon, all of these carbon groups, all of this volume of space makes the primary carbon too sterically hindered for an SN2 reaction. The beta branching of this particular leaving group means the reaction will not occur at the primary carbon. It will instead occur at the secondary carbon. So our product will arise from reaction at the secondary carbon. So let's make sure we get all of our carbons in this molecule. The primary bromide will still be here, the two methyl groups will still be here, and the SN2 reaction will take place at the secondary position with inversion of stereochemistry. This is the product when this reagent is reacted with excess of cyanide.